Hey everybody, this is Miss Norm back with another video. Do me a favor, pause the video, give me a like, and if you're not a subscriber yet, please subscribe, and then come back to the video and let's get started. All right, buddies, we are working on Module 6, Lesson 11, and Grade 5, okay? In this particular module, we're working on the relationship between X and Y coordinates on a coordinate grid or plane, using those algebraic rules that they have provided for us. So remember the x plus 1 equals y, x less than 3 less than x equals. So we were talking and determining the relationship. What would be the y coordinates, the relationship between x and y coordinates if we follow the given algebraic rule. Okay, so let's get started. This is a lesson 11 problem set, and this is a little bit more of the same, except for they added an extra step. So when you go into your algebraic thinking, you have those steps 1, and we have to determine the missing value, and sometimes we have 2 steps. We have to add and subtract in the same problem. Sometimes we may have 3 steps. So this is what we're working on today. If you have your paper and pen, that's fine. Some of the students have their packets. You can use your packet as well. Let's look at number 1. Complete the table for the given rule. Now, this particular rule says double the x. What does double mean in math, 5th graders? Or the rest of the world, whoever is listening, okay? Double the x, okay? That means we multiply x. When you double the x, you either add it twice, okay? Or you multiply it by 2, whichever is easier for you. So if I were to double the number 10, I can add 10 2 times. 10 plus 10 is 20. Or I can multiply 10 2 times. 10 times 2 equals 20. So this particular rule says to double the x. So let's double the x. Multiplying by 2 is a lot easier for Miss Germ. So let's multiply by 2. Don't forget, if you want to add, you can just add x 2 times. So let's go to the first x coordinate. 0. Okay? 0 times 2 equals what? 0. Very good. And I want you to go ahead and write your coordinate pair. So x is 0. When x is 0, y is 0. Okay? Let's go to the next one. And I think I'm going to run out of room. Let me see if I can make this page a little bit bigger. Here we go. Very good. Okay, let's get back to it. Let's look at the next x coordinate. So when x is 1 that we have here, what would be the relationship with y? Don't forget to follow the rule. 1 times 2, or double the x, double the 1, equals what? 2. Good. 1 plus 1 is 2. 1 times 2 is 2. And don't forget to write your coordinate pair. All right, next one, 2. Double the 2 is the rule, so let's double the 2. 2 times 2 equals 4. And I'm going to write the coordinate pair here. Don't forget to write your coordinate pair. X is always first. And then the last one, 3. We double 3. 3 plus 3 is 6. Or we can say 3 times 2 equals 6. And our coordinate pair is 3, 6. All right, they want us to plot, but I'm going to go, since I have the page enlarged. Let's go to the next rule. Here we have a 2-step rule. This particular rule says, algebraic rule says, double the x and then add 1. So we already know when they say double the x, we either multiply by x or we add x 2 times. And then when we finish doing that step, we have to add 1. Okay? So let's get started. When x is 0, we can do 0 times 2. Plus 1, or we can say 0 plus 0 plus 1. 0 plus 0 is 0. 0 plus 1 equals 1. Good. So when x is 0, y is 1. That's their relationship. So here, let's write our coordinate pairs. 0, 1. Okay. Let me erase, give myself some room. All right, let's go to the next, x coordinate. When x is 1, we have to double x, okay? So we can do 1 plus 1 and then add 1. Or we can do 1 times 2, okay? And then add 1. Both of them follow the same rule, double the x. 1 plus 1 is 2, or 1 times 2 equals 2, plus 1 equals 3. So when x is 1, y is 3. Very good. Let's keep going. I'm working on making the video shorter. Let's keep going. Okay, what about when x is 2? 2 times 2 plus 1. 2 times 2 is 4. 4 plus 1 equals 5. Good. So when x is 2, y is 5. And then the last one here, 3. 3 times 2 plus 1. 3 times 2 is 6, plus 1 is 7. When x is 3, y is 7. 3, 7 would be our coordinate pairs. Now let's get ready to plot on our grid. Okay? So let me see if I can make the page smaller. Move it over. Here we go. Very good. Alrighty. The first pair, and I'm going back up to the top where we started here, okay? The first pair, and oh, don't forget, you all analyze your quadrant or your coordinate grid just to see what are the values here. So here on the x-axis, I have 0 and 2, okay? So there's a whole number missing. The whole number missing there would be what? 1, good. From the next two numbers or values here, I have 2 to 4, and there's a whole number missing there, 3. And then 4, 5, 6, 7, 8, 9. It just makes it a little bit easier. Here we're missing 1, 3, 4, 5, 6, 7, 8, 9. Easier on you when you get ready to plot, okay? So always try to go in. They won't always be whole numbers. That's why you go in and analyze. Sometimes you'll have fractions in between, and we've talked about that on prior videos. So don't forget, go in and analyze your quadrant or your coordinate grid before you get started, okay? All right, now we're able to plot. The first one is 0, 0. So now let's plot here, 0 on the x-axis, 0 on the y-axis, okay? The next one is 1, 2. I'll go over to 1 on the x-axis, which is here, and then up to 2 on the y-axis, which is there. And then I'll plot. The next one is 2, 4. I'll go over to 2 on the x-axis and 4 on the y-axis. Remember, x-axis always goes first, okay? Here, and I'll plot here. Last one, 3, 6. We go over to 3 on the x-axis because the number 3 is first, the x-axis, and up to 6 on the y-axis. So our plot is there, and I'll go ahead and plot. When you finish, I want you to connect your line. Try as best as you can here to make a straight line. I'm on the iPad writing, so it's a little difficult. That's okay, but they give our line a name, which is here. This is line. It looks like L. And I'll draw a segment over the top, or you can just write line L. Let's move on. All right, the next set. The first coordinate pair is 0, 0. So I'll put that line, that coordinate there. The next one is 1, 3. So we go over to the one on the x-axis and up to 3 on the y-axis. Okay, the next one is 2, 5. We're going to go over to 2 on the x-axis and up to 5 here, back down here on the y-axis. And so our plot goes there. The next one, 3, 7. Okay, we're going over to 3 on the x-axis and up to 7 on the y-axis. And our plot goes there. All right, buddies, next thing you have to do is connect your dots. Remember, our first dot was plotted at 0, 0, so I have to start down here. I have to try to draw your line. I tried to draw a straight line, okay? Let me see if I can make it a little bit straighter, buddies. Okay, let's try that again. All right, just a little bit better. All right, they gave this line the name line M. And then we'll draw our line segment above that. All right, so let's go down to the questions they have here for us. It says draw a line on the coordinate plane above. That's what we've done. Draw each line. Compare and contrast these lines. So we know that compare and contrast means things that are alike and things that are different. All right, so let's compare and contrast. What's different? What's alike about these two lines? Lines L and lines M. All right, they both are diagonal lines. Good. What about, are they parallel? No. Good. Tell me why. Why are they not parallel? We talked about that. Parallel lines. Why are they not parallel? Okay, because they cross each other. Very good. So that will go on the difference, the contrasting points. Not parallel. Okay, anything else that's alike? Anything else that's different? If you look here, they both have the same x coordinate. Here, both have the 1 for x. They just have a different y coordinate. It looks like the same thing here. 1 for x, and they have a different y coordinate. I'm running out of room to write, but we know that is also a comparing and contrasting point. Okay. All right, let's continue. C says, based on the patterns you see, predict what the line for the rule double x and then subtract 1 would look like. And then draw the line on the plane above. Double x and subtract 1. So we already know what double x, what that line would look like. And that's our blue line. That's here. Okay. We know what double x and then add 1 would look like. And that's our green line, which is above the double x line. Where do you think double x and subtract 1 would belong on our coordinate grid? Do you think it would go above line M, in the middle of line M and L, or below line M and L? Pause the video if you need to think. All right, great. I hope you said below line M and L. Let's talk about why. If double x is plotted here, here we doubled the x and added something more, the values are going to be higher than just double x. Then if the next rule says double x and subtract, take away from x, okay, then those values are going to be lower than double x, okay? Very good. It says draw that line. So let's use red. All of them have started at the origin, 0, 0 coordinates. And it would be maybe something like that. Okay? Very good. Let's look at the next points here. Let me see if I can move this. I hope so. Thank you. It says circle the points that the line for the rule multiply x by 1/3. So here's our rule. Multiply x by 1/3 and add 1. So we are multiplying x by 1/3 and adding 1. So x times 1/3 plus 1. Okay? So it says circle the coordinates that would contain, circle the points that the line for the rule x times 1/3 plus 1 would contain. All right, let's see if we can think it out first. Okay? This means x times 1/3 plus 1. Let's see if we would get these coordinates. So let's look at the first one. When x is 0, so that means 0 times 1/3 plus 1. They're saying it should equal 1/3, okay? Because here, when x is 0, y is 1/3. So let's work it out. 0 times 1/3 equals 0. 0 plus 1 equals 1. That is not the same as y being 1/3, okay? Y is 1 in this scenario, so this one is not one of our choices, okay? Let me erase and give her some room. Give ourselves some room here. And if you're writing on your paper or you need to pause the video, come back, write, pause, come back, whatever you need to do, okay? Here we have 2 as x. So 2 times 1/3 plus 1. And they're saying should equal 1 2/3. So let's see. 2 times 1/3. We know we multiply fractions. We multiply straight across. Numerator times numerator equals 2. And denominator times denominator. 1 times 3 equals 3. 2/3 plus 1 equals 1 2/3. Good. And it does match our x there. So this one is very well a plot on our coordinate plane. And let Ms. Durham give us some room. And here I'll put a heart or a smiley face to let us know that that is one of our rules. Let's go to the next one. 1 1/2. When x is 1 1/2, y is 1 1/2. It seems like nah, but let's just try our ruling just to see and make sure we're correct. So let's look. 1 1/2 is our x times 1/3 plus 1. Okay, so we know we have to change this into an improper fraction. So 2 times 1 plus 1. 2 times 1 equals 2 plus 1 equals 3. So this is 3 halves. Keep the same denominator. Times 1/3. Multiply straight across. When you multiply fractions, 3 times 1 equals 3. And 2 times 3 equals 6. And then we add our 1. 3 6 plus 1 equals 1, and 3 6. This can be reduced. 3 6 can be reduced down to half. Very good. 3 divided by 3 equals 1. And 6 divided by 3 equals half. So the answer is 1 and 1/2. Very good. And just like they have here, 1 and 1/2. So that is very well a possibility that would be on our line. Okay, give me a chance to erase. Give us some room. We have one more just to check. One more just to check. I'll draw a heart because that smiley face. Sorry, you all. It's hard with the iPad. We have x as 2 1/4. So 2 1/4 times 1/3 plus 1. And they're saying it could be possibly 2 1/4. So let's see what happens. You know 2 1/4 is an improper fraction, so we need to multiply and add. It's a mixed number. We need to multiply and add to change it to an improper fraction. So 2 times 8 is 8, plus 1 is 9. And you keep the same denominator. And then times 1/3. When you multiply fractions, multiply straight across. 9 times 1 is 9. 4 times 3 is 12. And then we add 1. So this equals 1 and 9/12, which can be reduced. Our common factor there is 3, so let's reduce by 3. 9 divided by 3 equals what? 3. And 12 divided by 3 equals 4. So with this case scenario, y should equal 1 3/4, and y does not equal 1 3/4 there, so that is not one of our coordinates, okay? Really short lesson today, and I want to shorten the videos. The next page in problem set is more of the same, you all. And I want to show you just so that you can see, okay? Let's go to the next page. Problem set just like we did before. And I think at this point, most of my students, especially if you've been watching the videos, okay, you all kind of like experts at this by now. So I'm not worried. I know that you know how to do this part here. They want you to follow the rule. Here, the rule is half x. Okay, that can mean two things, and I'm glad we said that. When you want to take something and split it in half, if you had $10 and you wanted to split that $10 in half, what would you do? Yeah, you can divide by 2, or you can multiply by 1/2. And if you really absolutely need to, we can draw 10 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we can split them into 2 circles. I'm going to take 1 and put it there, 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 until all of them are gone, okay? That's only if you need to. Everybody's at a different level of understanding. Only if you absolutely need to. But some of us will just divide by 2. Or you can multiply by 1/2. Both of those methods really mean half, okay? So you take x divided by 2, or you can take x and multiply it by 1/2 to get your values. When you get your values, I want you to go ahead and plot on your quadrant or your coordinate grid here, okay? Same thing for the next one. They have line M, and they give us the rule half x, and then add 1 1/2 to that. Don't forget this part. The add 1 1/2 when you finish, because some of you are going to stop it at half x. No, add 1 1/2. And the same thing like the first page, you all. Draw your lines on your coordinate grids. And then they want you to compare and contrast these lines. And then based on the pattern, we have to predict. Okay, if the next rule was half x, then subtract 1, where would the line sit? Would it sit above those lines, below those lines, in between those lines? And then they want you to just give a rationale. Give your thinking, okay? Justify it. It's always possible, and it's always necessary, you all. All right, number 4 says circle the points on the line which follow this rule. Multiply x by 2/3, then subtract. I want you to go ahead and do that. And then explain how you know, and then give 2 extra points on that particular line. You can give any 2 points. You can draw your XY coordinate grid. data grid. Yeah. And then here, we're going to use the same x because they've used the same x coordinates all along. The first one is 0, 1, 2, and 3. Okay, but they want you to use this rule here. Multiply x by 2/3 and then subtract 1. So 0 times 2/3 is 0 minus 1 equals a -1. Okay. The next one, 1 times 2/3 minus 1. That's what you would do here. The next one, 2 times 2/3 minus 1. Same thing for all of them. Okay. All right, Ms. Durham's going to go to the next page. Here I have your homework and your exit ticket posted online. Some people are taking screenshots, which is fine. And they're writing on their screen just like Ms. Durham does on the iPad. That's perfect. It's wonderful. Whatever you have to do. Some people are typing on the screen. That's really awesome and really, really neat. Way neater than Ms. Durham writing on the screen. Shout out to Julianne on that. Very good, sweetie pie. And then some people have to write on a paper, which is also fine. I know a lot of people who really like or really enjoy actually writing on paper to complete assignments. And then you just take a screenshot and send it to Ms. Durham. So here's your exit ticket. You can pause it if you want to. Okay. And then here is homework, page 1. Easy stuff. My students are amazing. Anybody who's watching, Ms. Durham is willing to help out. The world, teachers, parents, substitutes, anybody who needs these videos. I know it's not easy, especially when you first jump into this particular curriculum. And then some of us haven't even been exposed to the new way of doing math here, or new thinking, okay, surrounded by math. So whoever it helps, I hope it helps many people as it can help. All right, send the video to somebody if they need help. All right, you all. All right, that's it. This is page 2 for homework. And Ms.